Algebra 1, Lesson 11, Solving Equations with Roots and Exponents. I know you all probably saw this coming. There are always patterns in math. Nothing is really all that unpredictable. We talked about operations with expressions, variables, and so far, we talked about most of those operations with solving equations. So it's easy to deduce that we could use the rules of exponents and radicals to solve certain equations as well. Let's start off with a simple example. Example 1. 2x equals the square root of 16. Note that you could rewrite the square root of 16 as 4. Now the equation would look like 2x equals 4, and you could simply divide both sides of the equation by 2 to solve for x, which equals 2. We also need to be reminded of the inverse relationship between exponents and roots to help us solve equations, just like we use the inverse relationship between multiplication and division. We can combine the rules we learned from previous lessons to manipulate equations so that we can isolate and solve for the unknown variable. Let's say we are trying to solve the square root of x equals 6. We can solve this intuitively by already knowing that the square root of 36 is 6. But a lot of the equations we will be solving will require more work, especially when we add more operations to them. Example 2. The square root of x plus 1 equals 17. In this example, it is not too intuitive what x could be, so we must do some more work. If we remember, exponents and roots in most cases undo each other. The square root of x raised to the second power is just x. The cube root of x raised to the third power is also x. You can already start to see a pattern. So, to solve an equation with a square root of an unknown, we need to isolate it on one side and then raise it to the second power or square it, so that we end up with just x. We also have to, as always, keep track of our operations on the side of the unknown variable, and apply them to the other side of the equal sign as well. Going back to our example, we can see that we need to get the square root of x by itself on one side to make life easier. We need to get rid of that one by subtracting it on both sides. So now we have the square root of x equals 16. To solve for x, we need to raise the square root of x to the second power or square it. Remembering we must also raise 16 to the second power, we end up with our final answer. X equals 256. We can also use the inverse rule to solve equations with exponents. For example, x cubed equals 64. In this example, we can simply take the cube root of both sides to get the x by itself on one side and balance the equation on the other side. So we end up with the cube root of x cubed equals the cube root of 64. The cube root of 64 happens to be 4, so our final answer is x equals 4. Let's take all our previous knowledge and solve this challenge problem. Note: it is important to know basic arithmetic when solving these types of equations, because trying to figure out what 9 cubed is may require some extra work if you don't have a calculator. Final example: solve the following equation. The cube root of x plus 1 equals 9. You will notice in this example that we are adding 1 to the unknown variable. In this scenario, we must remember our basic radical rules and not split them apart, but to treat them as one expression. So when we raise the entire left side of the equation to the third power, we are left with just the term x plus 1. But wait, that means we need to have 9 cubed on the right side. Does that sound familiar? If you punked out and got a calculator, you'll find out 9 cubed is 729, but we still need to get the x on the left side by itself, so we subtract 1 on both sides. That means our final answer is 728. It is important that you get practice with operating on exponents and radicals, and know the rules of them like the back of your hand. Knowing them, as well as the basics of solving equations, will help you get through the knowledge checks and future quizzes and exams. Now to move on to another class of equations in the next lesson. See you there.